Exponential notation. We've already discussed a number squared where we have a base, and this was called our exponent here. But whenever we write a number with a base and an exponent, that is called exponential notation. We've already talked about squared numbers, so I'm not going to go into that. You can look at my other YouTube video. But numbers that we have can be written in exponential notation. Later on, this is going to lead us to what we call scientific notation, when we're talking about really, really big numbers or really, really small numbers. Okay? So to make our lives a little bit easier, because otherwise the numbers get so big that they really don't mean too much. So to help our little brains decide what we need to do. So for example, if I have 5 to the third power, that equals 5 times 5 times 5. Okay? And the numbers will get big pretty fast. Okay? 8 to the fourth power would equal 8 times 8 times 8 times 8, and so forth. We notice that our base is the number that we will repeat over and over again, and our exponent tells us how many times we need to multiply the base by itself. In this case, 4, and in this case, 3 times. Okay. Now, the students will have to know later on how to write a number in exponential notation. Sometimes we might have 2 to the third power times 3 squared. Okay? And what does 2 to the third power times 3 squared means? It means 2 times 2 times 2 times 3 times 3. Okay? Now I know that 2 to the third power, 2 times 2 is 4, 4 times 2 is 8, that equals 8. I know that 3 times 3 is 9, 8 times 9 equals 72. So, the students will be given a problem to find all the factors of 72. Now I know that's an even number. I'm going to go ahead and start off with a 2. Well, I can start off with, make my life easy, 8 times 9. Okay? 8 is equal to 4 times 2, and 4 is equal to 2 times 2. So on this half right here, I'm down just to, these are all prime numbers. And notice that these are my 2's here. 9 is equal to 3 times 3, and these are also prime numbers, so we're kind of finished. We finished with that half, we finished with this half as well. Okay? And that's how we end up starting off with this. And the students are going to have to change this to this. So let me go ahead and try it with one other number. Let's see here. I'll try something, let me see, 60. Okay? 60 is equal to 10 times 6. 10 is equal to 2 times 5. 6 is equal to 2 times 3. So this would be written, first of all, as a factor string. 2 times 2 times 3 times 5. Okay? I just like to put the numbers from smallest to biggest. Okay? In exponential form, this would be written as 2 squared times 3 times 5. These just have a little exponent of 1, but we just don't draw them on there. Okay? one more quick number. Let's try 80. 80 is equal to 10 times 8. 10 is equal to 2 times 5. 8 is equal to 2 times 4. Prime number, I stop. That's a prime number. I just need to continue with the 4. That is 2 times 2. So here are my ending numbers. So I would write this as a factor string first, as 2 times 2 times 2 times 2 times 5. So written in exponential form, 80 can be written in exponential form as I'm going to put all of these together. My base is 2. I have 2, 1, 2, 3, 4 times 5.